let's get started. Firstly, maybe some of you have seen this beautiful video. I will leave link in description. Yeah, link in description. Just you can always see this. In that video, the man did some math for fun, and he got this. If we name by a arrow b a to the ln b, then suddenly it's commutative, and even it's associative. Suddenly, you can easily prove that. And even distributive with multiplication. But I gone further, and a bit earlier. Oh, sorry. So, 10th of April, I posted this. So I found, I got this table. If we enumerate operations from addition to this weird operation, and we call addition first, multiplication second, and this weird thing third, then nth operation is distributive with its neighbors, with some left distributive, with some right distributive. So all this rules working. Yeah, and more than I can show you another thing. Thing. So, natural element of nth operation becomes absorbing element of n plus first operation. Wow. Null becomes absorbing. So 1 becomes absorbing. You can easily prove that for these 3 operations. Yes. And there's opposite operation, and there's only one opposite operation because of commutativeness of this operation. So, and some other things. But what if we will just say that there's some operation like this, like a to the a to b, like that looks like this: e to the ln a times ln b. Whoa. Suddenly this operation is commutative, associative, and distributive with that operation. Wow. So let's prove some of these states, I think. For example, e to the ln oh, I have no space. A b c. No, that's a bit boring, I think. That's a b c. We want to prove that this is a b. Sorry, a to b, 1 a to c, where a b is a to the ln b, and a to b is e ln a times ln b. So that's true. I will give you a spoiler. So because of simple math tricks. Just many times power ruling, and only once you use this formula. The proof looks like this. So, but what if I want to A and B? What would it look like? Like what? Like what? I can. I know already that A null B is A times B. A 1B is is A ln B, is e to the ln A ln B, and now we know that A to B is e to the natural log of A times natural log of B. What comes next? You can prove that, and so I proved already that if we will think that this is true, A and B exp n times of ln A ln B, that all that rules will apply. What does mean exp n of x? Exp n of x means e to the n times to the x. Ln n x means same thing. It means ln of natural log of x n times. And we need one more thing, that exp minus n of x equals ln n x. This formula we need to. So now we can generate these operations from first to positive infinity for omega. Yeah. But what is before addition? What if we go to the opposite direction? We have formula for next operation, but have we formula for previous one? Now I need to just delete this thing. Yeah. We know that A to the and B is equal to exp n ln A ln B. We know then exp minus n of x equals to ln n x. Okay. Firstly, if we try to get addition this way, we will get it. Firstly, multiplication A null B is exponentiate null times and natural log null times of A times natural log null times of B. Obviously, exponentiate null times means doing nothing, as well as ln natural log null times x equals x. So this is A times B, and then if we want to find addition this way, we will find it. This is x x minus 1 of ln minus 1 of a times ln minus 1 of b. We can flip this. It's ln of e to the x of b equals to ln of e to the a times e to the b. Power, we'll use power rule. It's e to the a plus b, and it's a plus b. Suddenly, okay. And then what's before? What's before? Equals to b. What's before the addition? That's fine. But before this, we will find more general thing. What is a minus n b? Is x minus n of ln minus n a times ln minus n b. But this is ln n of x n a times n b. But that is ln n minus 1 of exp n minus 1 a plus exp n minus 1 b. Because of power rule. So before addition we have this operation. It's really weird. Here it is. This operation is commutative, associative, distributive with addition, and is before addition. Means it's right or left distributive. I don't remember, but I always can get result. Well done, well done. But what about natural element? For addition, this is null. For multiplication, e with the index is natural element. For nth operation, natural element of multiplication is just 1. Natural element for that where the operation is e. But what is neutral element? We remember from that table that maybe neutral element becomes absorbing element next operation. Means we show neutral element of minus second operation is absorbing element for addition. Absorbing element for addition is what? A plus b equal to a, b equal to o. But what if b doesn't equal to o? What if, for example, a plus 5 equal a? So it could be infinity. So infinity isn't number, isn't a number. We could then we could write down limit f x approaches infinity, a plus x equal to x, where a is a constant. So nice. Maybe e with the index minus 2 is infinity. Let's find out. A minus 2b is equal to ln of e to the a plus e to the b. That means what does it mean? We want find such e that this is just a. Write equation. Write down equation e to the a plus e to the e with the index -2 is equal to a. E to the sorry, I have no place again. Let's delete this stuff. God. Finally, e to the x of both sides e to the a plus e to the natural element minus second operation equal to e to the a. Means e to the neutral element is null. Means that neutral element is natural log of null. But what is natural log of null? If we write down limit, if x approaches null, ln of x, we got negative infinity. Yes, as we thought a bit earlier, this is some kind of infinity, and you can easily prove that nth neutral element is e titration n. Titration is I mean a titration b is a to the power of a to the power of a b times. For big operations like this one or that one, it's e to the e to the e to the e many times. But for less and less operations, is ln of ln of ln of e. And the neutral element gets weirder and weirder. So neutral element for -3rd operation should be ln of negative infinity. Nice. It's just complex infinity, maybe. Don't really know. Maybe. But it works. This table complete. These are all properties, or kinda all properties of operation here. But I want find operations such that it's between addition and multiplication. It's kinda this. I want to find this operation. What should it be? I mean, if there is some n in formula, I want n be real number or even complex number. By definition, A05 B should be x 0.5 of ln 0.5 a times ln 0.5 b. But what is x 0.5 of a? It's just such function f that f of x equals e to the x. I think it would be the function that would be function at between the line y equal to x and exponent curve. This curve. Graph will look like this. Maybe. How can I find this function? For any point of red graph, the distance from this point to line y equal to x is equal to distance from this point to curve, but I don't know how to find distance from dot to curve. Come on, I am 11th grader. Oh, about that operations, I forgot to mention interesting thought. Why B should be A times B? Why null operation is multiplication? I think we can it would be good that most common relationship between two values in physics will be the null operation. I heard somewhere that every physical value, every physical quantity is kind of vector in some space. Maybe very exotic space or yeah. And if you have some apples or something, you can easily multiply it by natural number. But what is for example 5 apples plus 1 what? It's weird. I think this is because we exponentiate not null times. Not null times. A to them. But why a to the power of b is mistake? A to the b in terms of the separations of holy crap is a e to the b. How can we describe e to the b in terms of these operations? What is this? I think we should think about e to the b like hyperbolic sine of b plus hyperbolic cosine of b. Oh, you write it like that. I mean, that's the same thing. And it's look like cosine of I times b minus I sine of I times b. Yes, like this. It's about trigonometry, not about another piece of algebra or something. Power is kind of mistake, I think, because look at these formulas. This operation is absolutely symmetric and endless. Wow. I know that symmetry is about group theory, but come on, this problem, I don't know what to do with this. I'm in 11th grade. Come on. That's all. I think I have no any thoughts. Yeah.